Thanks for watching this code walkthrough video for the Best Price store. There are several special features and some styling that I will look at in separate videos. But for now, I'm going to show you a small sample of the foundational code that really makes the program work. Let's begin with a user accessing the website. This will trigger the index action in the home controller, which will return the view with the same name in the home folder. The index view is straightforward. We have one column with a header, some paragraph text, an image, and more paragraph text. In the second column, we have another header, some paragraph text, and another image. It's also good to note that every view relies on the shared layout view. The shared layout view contains the header and footer and then renders the other views as the body content in between. The header contains the navigation links. The home page link is always present, but there are if statements to determine what other links are displayed. For example, if the user is not logged in, there will be links for student login and admin login. If the user is logged in as a student, there will be a link to the store page. If the user is logged in as an admin, there will be a link to the store dashboard. If the user is logged in as either a student or admin, there will be a link to log out. Let's imagine that the user clicks the admin login link. In the shared layout code, we can see this triggers the login action in the admin controller. The admin controller says to return the login view. I'm going to share in detail about the authentication and authorization functionality in a separate video, so let's skip ahead a bit and pretend that the user has completed the login process successfully. This will trigger the overview action in the admin controller, posting the admin's email address. In the overview action result method, we're going to ignore this try-catch statement, as I will be discussing error handling and data validation in a separate video. For now, let's look here, where we create a variable called stores. It takes the instance, repo, which if we scroll up, we will see it's a read-only object of the iAdmin repository type, and calls a method listStores, passing in the admin ID. We can open the admin repository class and view this method's code. So it's going to return a database query. It's going to do a SQL join because we require information from both the admin table and the organizations table. It's going to select all the data where there is a match between the admin ID that was passed into the method and the admin ID column in the database. Essentially, this means every organization or store that has this admin ID will be returned as a list of IEnumerable variable and saved as stores. Let's skip this next part that has to do with authentication until we return the view called Overview, passing in the stores variable that contains data for all stores associated with this particular admin. On the overview, the model indicates which data type is in use. In this case, a list of stores, or an IEnumerable of organization. There is a brief message that login was successful and to select your store. Then there is a table with a single column. The header is store name. Next, we enter a for each statement that iterates through every store in the list that was passed in. For each store in the list, a new row is added, with the name of the store displayed as a hyperlink. That hyperlink redirects to the organization controller's index action, with the organization's ID as a parameter. Let's imagine that the user clicks that link. We go to the organization controller and look at the overview action method. We've passed in the organization ID. We declare a variable store and assign it a value by calling the openStore method in the organization's repository. In that method, we pass in the organization ID, query the database for all data pertaining to a single store that has the matching organization ID, and return that store as an organization object. Ignoring the authentication for now, we then return the view called Overview with the organization object store as a parameter. Once again, we use the model keyword to identify the data type. In this case, the single organization object we just passed in. This gives us access to all of that object's class members. We use model.name to display the name of the store and model.storeStatus to display whether it is open or closed. There are a number of links corresponding to various actions and controllers. Let's imagine the user clicks on the link to view, modify, or add students. This triggers the overview action in the student controller. Let's ignore the authentication if statement for now. We declare a variable, students, and in order to assign its value, we call the listStudents method from the students repository. This is very similar to the listStores method we saw earlier, except it queries the database for all students with an organization ID matching the ID that was passed in. It returns the query result as an IEnumerable of students. Going to the student controller, we then return the overview view with the IEnumerable students as a parameter. In the view, we set IEnumerable student as the model's data type. There's a title and some text, and then we begin a table. Here is the header row with 5 columns. Next, we have a for each loop that iterates through each student that was passed in, displaying their ID, name, balance, category, and status. Their name also serves as a link to the index action. Below the table, there is a link that triggers the Add Student action. Let's imagine the user clicks that link. Going to the student controller, we find the Add Student method, and once again, we'll skip the authentication piece for now. The next 2 lines have to do with data validation, which we will also skip. The method returns the Add Student view. The Add Student view uses the student model and contains a form to enter information for the new student. For each property, we have a label and an input box, where the user can enter the information. Each input name corresponds to a property, and the default value is an empty string. Notice that 2 of the inputs, student ID and organization ID, are hidden and do not have a corresponding label. This is because they are the primary and foreign key, and we don't want the user assigning them values. The student ID will be auto-generated, and the organization ID is determined by which store the student is affiliated with. We'll ignore the for each loop that's for data validation and look instead at the final input field, which is a submit button. If the user presses this button, it will trigger the action identified at the beginning of the form, the Save New Student action in the student controller. That new student's data is passed into the Save New Student method as a student object. We call the Add Student method from the student's repository with the new student object as the parameter. The Add Student method inserts a new student into the database with the values that were passed in through the student object. This SQL statement is parameterized, as it uses variables for each value. For example, we have @studentName representing a value to be inserted. Then we set that student name variable equal to student.studentName. Student is the object that was passed in, so we're using that object's student name property. Once that's complete, we go back to the student controller and see that the next step is to redirect to the overview action. which, as we know, loads the store dashboard in the view. There are dozens more actions and views in this program, but they generally follow the same type of logic I showed you in this section of the code. Thank you for watching this video. I hope you watch the demo video as well as the other development videos.